Can you hear me?
Yeah.
Okay, thank you. So, good afternoon. I get to speak about nothing as interesting as the Internet of Chocolate, but I get to talk about making interfaces sound human because I set up a stealth AI lab about 7 years ago, much like SRI, just with a much smaller budget and a much narrower focus with my co-founder and chief scientist Raj, who's one of these uber brilliant scientists, much like Richard on Pied Piper. And I often say things like 90% of AI startups don't know their AI from their a-hole, because it's amazing. Everyone's an AI company now, even if you're not doing anything to do with AI. And being on the business side and saying things like that probably makes me more like this guy. But our focus on with this lab was how do we create an interface that sounds human. And by sounding human, we don't just mean has a voice and a voice that sounds like a human voice. It's about how do you make that interaction much like you would with two humans. And so it was this, for us, the philosophy behind it was that the best interface is none at all, right? And so if you can get to this point of the zero interface, then you're going to have likely the best experience with the user and the device. So we've spent a lot of time thinking about what interfaces will be like, what does the interface of the future look like. And it's pretty clear now with all the trends that you've seen that it's going to be powered by AI. It's going to be intelligent and sentient and ideally barely there. And the reality is that this is the big change from a designer's perspective. Adobe Illustrator is the old AI. And this movement from HCI to kind of human AI-powered approaches that hopefully many companies are taking is the root of what we focused on. So we think there's four things to really think about. The reality is that traditional screens are rapidly going away, right? Whether it's voice inputs, gestures, sensors, patterns, they're the new touch and type. You think about the screens that we're starting to see in our lives now. Traditional screens are starting to go away. Already this is much smaller than the phone screen. Your cars have big screens sometimes, but at other times you're expected to just focus on the road ahead, so you can't be looking at those screens. We're getting to smart clothing, where you have no screens at all. In your smart apartment, you'll have a device that perhaps today you think you talk to, like an Echo. The reality is there'll be 15 devices talking to each other, and you don't know which one you're talking to. As much as we think of being online and connected all the time, we in reality live in an almost always connected world. Not just for devices of the future, but even your phone, the always connected phone. Driving in from San Francisco, I had probably 3 of these moments, right? And so if you start thinking about your interface as being something that resides in the cloud, as a designer, you might be able to design for it, but from an experience perspective, it is a nightmare to think about the number of times your device won't be able to react to the user because the quality of the connection wasn't good enough, or you happen not to be at Wi-Fi. And the reality is that we're going to interact with about 20, 30 devices in the next few years. And it's hard enough learning how to speak to your phone and your watch and just your car, because even if the car is a CarPlay enabled device and you have an iWatch and you have an iPhone, their capabilities are different. And so you start learning how to speak to them. And so when you try and make a command to your phone, maybe to Siri or or Google Now, or Cortana, or whatever it is that you're using, you could maybe try and make, more full statements. With your car, you're going to say things like call, hope that it's picked that up, and then give the name that you're going to call. And you can imagine getting to a point where you're now talking to 20 devices, and you need to learn how to talk to each of these devices. It's, from a design perspective, from a user experience perspective, that is an absolute nightmare. And then if you think about, everyone's talking about bots, right? These smart chat bots, whether it's support, whether it's sales. How many of you have had the experience of chatting with a smart bot? Hands up. About 6. All right. And how many of you actually came away from that experience thinking, wow, this was great? All right, so that's 0% so far, right? And think of the challenge, right? You're 10 minutes into the conversation. This bot is kind of responding to you. And then you get this, let me connect you to someone who can help you, right? So you've got this exceedingly frustrating conversation that you had. You didn't get what you wanted. And it's a fine balance. Even the technologies that have gone a long way ahead in terms of how well they respond to you, it's a very frustrating experience because you need to find the right balance between I can get what you need done and I want to be engaging, right? So in context, you're trying to figure out why my account got locked and now we're in this loop and it's very frustrating. And so you ask me how the weather is or how my day is going and you're like, just get me someone who can help me, right? It's a very, very frustrating experience. And this is where a lot of our thinking comes into play. We believe that, it's not just about being accurate in terms of knowing that you got your word error rates right. People talk about, we're an exceedingly accurate system because we have, only 7% or 3% or 5% word error rate. Great, so I said a sentence or typed a sentence and you were able to get, only 7% wrong. But the reality of human interaction is that figuring out what I said is just a very base expectation. What makes our engagement really exciting is that we are able to unlock dimensions of data around what we say to each other. And being able to unlock that data is what makes these conversations really engaging, right? So our big approach to the interface of the future is you don't need to just understand meaning, but you also need to understand intent. There's a lot of systems that do this already. Alexa is a great example. You need to know context, and you're starting to see a lot of great demos around products like SoundHorn and Watson that do a good job with maintaining context. But from our perspective, one of the most important aspects of the future of this interaction is inference. Because human beings essentially operate on inference and not on declaration, right? So if I say to you, turn temperature up to 74 degrees, you're like, that's the last time you're visiting us at SAP, you rude fool, right? We work much better when I, for example, go, wow, it's like a furnace in here, right? And the inference of that is, oh, let me, turn down the heat or take off your jacket, right? The human brain works around inference. And in the lab that we created 7 years ago, we focused a lot on how do we mimic that aspect of the brain in the way that it processes conversation. And what we found is that our brains aren't defined by definitions or just the pure meaning of words or grammars. In fact, my English could have been terrible in terms of construct, but you would still understand for the most part what I'm saying. It's because the brain actually works on a circuitry of concepts. And we spent 7 years being able to capture that and put it together in an interface kit, because our vision was not to create a digital assistant. Because a digital assistant can sit in the cloud and answer just about any question to you. If you're designing an app for a game, you don't care to get directions from San Francisco to SAP Building 8. right? It's out of context. What you want is to be able to build as much context and concepts that exist in your game that might not be common English terms, so that the user can have the experience that you want them to have as a designer. So what we've created, we like to say we've created a 15-year-old kid. Maybe not that kid, someone like that. Polite and is able to understand conversation, understands nuance, understands inference, probably has no domain knowledge. So don't ask this kid how ETFs work, right? Or how an internal combustion engine works. But if you tell the kid how that works, the kid will not only have that knowledge, but the kid will also have the ability to apply some of the more general concepts that the kid has to this new knowledge. So for us, we focus on basically 5 things around what we've done with Zero AI and what we think of as the interface of the future. An interface needs to be local on the device. Today, Watson, Alexa, Siri, Google Now, you name them, they're all in the cloud. You call these APIs, right? So as an interface designer, if your touch and type SDK was in the cloud, you wouldn't have the apps and the kind of devices that we have today. So it needs to be local on device. Because it needs to be instant. You need to have the ability to do the customizing things that you want with it. And there's a financial aspect to it. Your data plan today might cover your needs for cat videos, but if you have your voice interface now, and the user is going to say 15 different things to that device every few minutes, you'll need a very, very large data plan for it to process both the voice and the natural language processing. And what we did was, when we created this concept-based architecture for our interface kit, we came up with new algorithms for voice processing, for natural language processing, and the AI pieces that combine all of it. That's very, very unique. Your interface needs to be designed for the real world. And the real world is between 20 and 40 decibels of sound around you, right? So when you have 20 devices that you're working with, it's not always going to be all silent. And so you need to be able to adjust, not just to background sound, by a primary speaker, hook on to that primary speaker, and then ignore everything else. And we did some very interesting stuff around that that's built into the product. You need to adapt to the user's speech, not vice versa, right? So if you have 20 devices, you're not going to learn how to speak to them. When you work around this concept-based architecture that we have, you don't care about each word. It's like being at a bar and chatting with each other. You don't hear every word, and it's okay. You get the general idea of the concept, and you build a circuitry around that, and you can have an engaging conversation. Obviously your accuracy rates, as I mentioned earlier, not just defined by word error rate, but how engaging of accuracy was there around the concepts that you spoke of. And so that piece of unlocking the multiple dimensions of data around your conversation, to us, that's accuracy. Getting to 97% accuracy from a word error perspective is a given, and the good systems are getting there in any case. And finally, and most importantly from a designer developer perspective, it's an interface. It's not a digital assistant. And so it needs to be extensible. It needs to be customizable. And I'll actually show you very quickly what that to us looks like. So if you're BMW and you kind of want to create a new concept around safety, right? You can do one of two things. You can go in and upload your big safety manual into our dashboard, and drinking our own Kool-Aid, we're going to be able to pick out all the concepts from that manual around safety. We're going to be able to pick out things like dynamic stability control, traction control, all things that are standard on a BMW. And we'll be able to score it. So we'll see how many times it's referenced, what needs to be elevated to being very important concepts. And then we'll look at the definitions of those concepts. And now it's being built in. And so that 15-year-old kid suddenly learned this whole stuff, right? Now by itself, that's kind of cool, now this interface kit of yours has this knowledge, you could go in and add your own if you wanted. So I want to add this concept of just the car. These are the synonyms. It's also called an Auto in German. It's called Gadi in Hindi. These are its plurals. The phoneme, what does it sound like, will generate by default, but you could then say, no, I also want this pronunciation for whatever reason. I also want to pronounce car and car or whatever. And then you can just define it in natural language. What is a car? You stick that in. And the really cool thing around this, and we'll go back to that example of dynamic stability control, right? Which was a concept that came in from that document. But let's look at what this looks like to the user. So by default, you want there to be no new interface, right? We didn't create anything in addition, because after all, the best interface is none at all. So you're sitting in your car, and you can imagine a conversation that goes something like this. And this is where the real power of inference comes into play. Because what our system learned was dynamic stability control is probably what keeps any wheel from spinning without losing traction. But
hey, Tara, I'd like to do a wheel spin.
A wheel spin? Oh, Amit, I need to turn off dynamic stability control. Are you sure?
Yeah, I'm sure about it.
Okay, I've turned it off. Please be careful.
so I'm not sure if you could hear that clearly, but the command I gave was, hey, car name, I want to do a wheel spin, right? And this is where the power of inference comes in. I didn't say, turn off dynamic stability control, because I don't know what that is. So I'm the average driver in the car, and I get in and say, I want to do a wheel spin. And the car comes back and says, sure, in which case I need to turn off dynamic stability control. Are you sure? And when you start applying this now across all the different devices, you get to a point where you can basically talk the way you talk, and the system will understand how to respond to you. So we think that these approaches effectively help make your interface sound human. So for us, the ability to engage with the human, whether it's listening to the human or looking at the gestures or sensing that the human is around, and to infer and engage in a way that we do as fellow humans is really taking your interface to the point where it sounds human. Thank you.
We have time for one question, so there's one question we can do this. Here we go.
Enthusiast.
Oh, yes. So this idea of the car is very cool. How would it apply in the home, with connected devices, the Internet of Things, this idea of inference?
So inference versus, so if you went to your apartment and said,
Like the Alexa or one of
or
those.
right, Alexa or your Nest device, right? And you would basically, if you were declarative, what you would do is you would say, turn temperature to 74 degrees. And, ostensibly your device would understand and turn temperature to 74 degrees. But from our perspective, you'll get to a point where you walk into your apartment and you'll say, I have Jane coming over for a date at 8 o'clock, get ready, right? And the first time you want Zero to come back and say, that's great, congratulations, what do you mean by get ready? And, with the whole Internet of Things, that could include turning on the fireplace, turning down the temperature, switching Pandora to smooth jazz, right? Getting the chiller on where the champagne is. And so the ability to go in and infer from that, Jane's coming back for a second date, at 7 p.m., get ready, and going back and doing that versus what you would do for Christina, is the power of where, inference really matters, and think of the future of interfaces.
Well, I want one in mind.
Okay. Thank you, Amit.
Thank you.
Thanks, everyone. We do a quick 3-minute break.